In this video capsule, we shall look into the installation process for installing the open source software packages onto our system such that we will be able to make effective simulation for this course. The plan is to install gEDA software toolset. This is the electronic design automation toolset. And then we shall install ngSpice, a very popular package for circuit simulation. And then after this, we shall install Octave. Octave is a MATLAB-like environment which is very helpful in scripting and automating many of your design tasks. So these three set of software packages we need to install. I will show you by taking a walkthrough and then configuring the system to our needs. I have a Fedora 23 Linux desktop. So I will show you by taking a walkthrough the process in this particular operating system. My students have checked it out on Ubuntu also, so I guess that it should be fine even in other Linux distributions. On Windows, I have not tried, nor have my students tried, so I am not too aware on how it will perform on Windows. So I suggest that if anybody of you are trying it on Windows, that is EDA, ngSpice and Octave, you can try and then let us know how it performs. Or you can use alternative packages, whatever is available on the Windows platform. With this, we shall start now the process of installing these software packages.
We shall begin the installation process by first downloading the resource from the Google Drive. This is the Fedora desktop, and let us open the folders. And here I have created a DC-DC converter folder, and within that folder I have downloaded this resource01.zip folder file. This is located in Google Drive, and the link for this is given in the course website. This has two folders and one file, a readme.txt file. There is a bin folder and a symbols folder. Of course, I will explain to you later what are the functions and how we will use that one. So for now, extract that, unzip it, and within that you see this folder. Readme.txt gives you a step-by-step instruction on how to go about this process of installation. So open that readme.txt file and keep it to one side, and all you have to do is follow through the steps. The commands are given here. You just may have to copy and paste it if it is a Fedora system, or equivalently type in the command line commands if it is any other Linux system. Again, go to the desktop and open a terminal. Let me adjust the size so that I will be able to see that. Now let us copy this and paste it here. It will ask for the password and then execute it. So in my case, I have already installed all these packages. it will search and look for the packages in the repository and install them. So you have the gsim check, the gsim docs, netlist, symbols, utils, gshem, the gEDA, gschematic. This is what we will be using at great length in this particular course. So dependency is resolved, nothing to do, everything has been installed. In your case, if you have not yet installed gEDA, you will see that it will give a list of packages and ask you whether to install or not. You say yes and it will get installed. Next, we need to configure gEDA. You can in fact open gschematics and see what happens, what pops up. So let me type gshem, enter, and you will see a GUI something like this opens up. There is a status dialog which opens, which just gives you an indication of the paths which from where it takes. This is the gschematic RC file, GAF RC file, where it is located. It is located in user share gEDA. However, these are in the this need root permission to modify these files. However, if you want to customize, you need to have a copy of these files in your user.gEDA folder, which I will tell you about shortly. Close this. This is how the gEDA user interface will look like. This is having a dark background. Some people may like this background, fine, but I would prefer to have a light background, and I would like to have the default GSM opening with a light BG. Now here is the components, and this is where you have the libraries, where a list of components coming here, and then you can choose these components to place onto the sheet. Okay, close this for now. We know that gEDA is installed, working and running, and it is opening up. At this point, I would like to configure it. I'll show you how to configure it to make it into a light background one. You may want to change it, or you may not want to change it. You may want to retain the dark background. It is up to you. But let me show you how to go about doing that. So you see here the readme.txt file, gnetlist. Just go through this command syntax, copy, and then paste. So this is just a gEDA command. What it would do is that it will create a .gEDA folder in the users root directory, and into that directory is where we would like to have the RC files. So if I go into home and do Control H or alternate the hide, it will show the hidden files with the dot prefix. So you see that this has got created .gEDA, and into this you have logs and a geometry file. Here we have to put the gshem.rc, the gaf.rc files. Anyway, we will come back to that later, and we will see what to do next. Next, we would like to make a gaf directory, and this is where we would like to place the symbols of gEDA, the custom symbols that we make, that has to be placed within this. So we will give it a place. So just copy this and paste it here onto the terminal and press enter. So what it would have done now is create this gaf directory, GAF. It is right now empty, but we want to fill it up with symbols, custom symbols. Next, we create within GAF another subdirectory called symbols. Now that is where we shall place our symbols. Copy, paste, and enter. This if2 then redirected to errors.log is just an indication. If there are any errors to see, you can go and look at this log file, see what happened. If there are no errors, nothing will be entered there. So now after having run this particular line within GAF, you would have this, and inside that let us place the symbols. So what we shall do, we go into this DC-DC converter folder, and within that we have the resource folder, and in that we have the symbols folder. In the symbols folder there are three subfolders. One is called A block, A bond, and A comps. A block has many symbols associated with add, clock, gain, integration, multiplication, PID, PWM bridge, PWM single phase, sample and hold, SR latch, summations, so on and so forth. So these are custom blocks, something more logic oriented, not much of power flow, and interesting to have them. I will come to this later. We may not be using this, but anyway, I would like to share that with you. The ACOMs are the component block. The default are the generic components: capacitor, default diode, a power diode, source, flow source, current source, a gyrator, inductance, power switch, resistance, SCR, signal switch, transformer, a transformer, bridge for bridge, another flyback transformer, forward converter transformer, push-pull transformer, and the normal transformer. So these are symbols which will be useful. This is particularly symbols used for bond graph simulation. So people who are familiar with bond graphs and have done bond graph modeling and simulation, they may use it. But right now we shall not use it. But however, I will share this folder also with you. You copy all these, copy and go into the GAF, go into symbols and paste them. And now we are in business. We have all the symbols in the proper directory. Now we have to assign the proper path. So now that we have done that, we will assign the paths and create the respective files. Now there are two commands here. One is a command, component library search, where it will search through this path. Dollar within braces home is an environment variable, which will take the root user's path, then into GAF and into symbols. Now this should be the path of all the component library search, and they should get reflected in your G schematic when you open it. And this is pushed into a file which is residing in .gEDA and into a GAFRC file. If GAFRC is not there, it will get created. So this is your own custom GAFRC file. It will search for there, and then see this, and then set the path, environment path. So we can have this copied and paste it here and run that one. So once you run that, if you go down into the hidden .gEDA file, I have unhidden that. So into that you will see that there is a GAFRC file that is created. So into the GAFRC file, see whatever we have typed, component library search, that would have come in here. So when gEDA opens up, it will look into this file, see this path declaration, and then appropriately remember the path. Next, we would like to make the background light. So that is this: load build path gEDA GSM-RC. Into that GSM-RC we will put this GSM color map light BG. So instead of dark BG, we want a light BG, and then put that into .gEDA GSM-RC file. So we will copy that and paste it here. So that would have got entered in there. So you see that GSM-RC has been created, and within that this has been copied. So it will look in there and automatically put in the proper background color. Now I will do Control H and hide all the .prefix files so that it doesn't clutter up the folders. Now you can run GSM. Now you see the background is light. You see that it takes gaf-rc from the local users .gEDA directory, GSM-RC also from the local. So it's working properly. You can open it to full screen. You can use the wheel button of the mouse to zoom in and zoom out, and then go into the components. Now you see that our custom libraries, A block, A bond, A components are reflecting here. So if I open it, you see they are all coming in here, the symbols, and that's very nice. And then the component. Now close this and back again to the terminal. Going back to the readme.txt file, the next part of the simulation is installing ngSpice. So installing ngSpice is pretty straightforward. You just copy this, dnf install ngSpice, and let me clear this terminal screen. Control L, and that is cleared. Paste. So sudo dnf install ngSpice, enter the password, and of course in my case here it is already installed. And in case yours is not installed, it will say that this particular package has to be installed, whether to install or not. Click yes, and then you will be through. And then after that you need to install TCL-Spice also, though actually you may not use TCL-Spice. There are some libraries in TCL-Spice that are useful for ngSpice, and kindly do install TCL-Spice too. And here again it is already installed here, and then you will get such a message. So now ngSpice is also in place, and if you want to test that, you just type in ngSpice --help. So that will give you a menu of options and how to use. Go through that, and I would recommend that you download the ngSpice manual and read through it if you don't know how to use Spice. It is very similar to pSpice of the Windows. It is actually evolved out of the Berkeley Spice, and quite universally used by many people. You can type just plain ngSpice, and it will go into the ngSpice environment. It is ngSpice version 26 plus, and developed by Berkeley CAD group, and then you have the ngSpice environment prompt. So I will quit from this here, knowing that ngSpice is working well. And now we have one more package to install, and that is Octave. Octave is a very powerful tool. You should have that. It is open source equivalent of MATLAB. Sometimes I find it much more powerful than MATLAB, but anyway, that is a good package to have on your system. Paste it here. I have used DNF install. I have used DNF everywhere during this process because this is Fedora 23. Fedora 22 onwards, we have to use DNF for the package installer as the package installer. Before Fedora 22, it used to be yum. So people having Fedora version earlier than 22 kindly use yum, YUM. And in the case of Ubuntu, people can use the apt-get package installer. So use this, press enter, and the rest the package installer will do the job. And here again you see everything is already installed and the dependencies are resolved, nothing else to do. Now to test whether Octave is running properly or not, just type Octave. You will now see a GUI popping up, a very nice GUI. It looks much like the MATLAB GUI. This is where the workspace window is, and this is where you will probably do all the work. So Octave is working. This is version 4 plus. Most of the earlier versions of the Octave, they may not have a GUI integrated, but it will work on the terminal just like the ngSpice environment. So if you want to work in such an environment, which I also prefer, you type Octave -- no GUI. So then you will get it in the terminal. This is very fast, and you will be able to do equivalently good programming with this terminal environment too. So let me quit that. And with this, we have installed 3 packages. One is the EDA, Electronic Design Automation. The next is the Spice, that is ngSpice and TCL Spice have been installed, and then Octave, and we have installed it on a Fedora system. I hope that you will not have a problem in other distributions too. Kindly follow it, and then look into help on the net too if you run into problems. And there is of course a forum to discuss. There is one last job which we need to do, which is the step 4, and that is something which you need not do, but something that I would like to share, and which may be of help. So this is not compulsory. So what I request you to do is, if you don't have a bin folder in your user home, create one. Create a bin folder. So you will see that a bin folder is created. Then go into the DC/DC. There is this bin folder. There are 6 files here: ngplot, ngsim, qplot, qsim, spice read file, and this update net.m. So you just copy all of them and go back there into the bin and paste. Fine. ngsim and qsim should be made executable. They both are Octave scripts. Octave scripts meaning that it starts with a hash exclamation user bin Octave. So it runs Octave directly from the terminal. So these are useful scripts. I will tell you more about this at the time when they are needed, but it's better you keep it ready. So to make these 2 executable, in the readme file I have put these 2 commands: change mod u plus x qsim. So they will be made executable. So what you have to do, go into the terminal, cd bin. So you will see that it has the 6 files: chmod u plus x ngsim. So So that will be made executable ch mod q plus x qsim, and that also will be made executable. So that's it. Your software installation portion is over. Next, we can start on building our simulation schematics and simulate the circuits. This portion, this installation portion, is one time, so it is worth putting the effort to do this work neatly and properly now, and then forget about it. Next, only you can think on circuits and simulation.